Okay. This is starting on chapter 4-2, and we're going to talk about what's called the SSS theorem and the SAS theorem. If any of you know who Mr. Fogel is, he has fun with these, and he gets this really funny Chinese voice out and goes, side, side, angle side. It's really funny. But so, I told you we'd be doing proofs. Uh-oh. Did I run out of ink? There we go. I told you we'd be doing proofs. This next section of Unit 4 is all about triangle proofs. So I told you Unit 4 was divided into 3 sections. We talked about the special segments. We concluded that and took a little quiz. Now we're going to talk about triangle congruence. We're going to have about 6 sections where we're doing nothing but proofs. I'm warning you now, you may not understand the proofs in the notes right now, but to have them down so that when you get to the homework in class, you'll have them as guides, and you can kind of use them to guide you through the homework, and then as you're doing the proofs, the more you do, the better you'll get at them. Okay, so this is called the side postulate. Okay, what it says is that if 3 sides of a triangle are congruent, then the triangles are congruent. So what this is saying is you don't have to prove every single part of the triangle congruent to say that the triangles are congruent. If you have just the sides, you don't need any of the angles. You can say that the triangles are congruent. So let's see what this looks like in a proof. So if I give you this example, this is A, C, B, D. Now, if you haven't learned the congruent symbols by now, you'll need to learn them for this part of the unit. Okay, these little marks, since they match, mean that these are congruent. These little marks, since they match, mean that these are congruent. The only reason why there's 2 here and 1 here is so that you know that these 2 are different from those 2. Okay, so do we have the 3 sides congruent? No, we only have 2, so we need to write a proof. We're trying to prove the triangle's congruent. Okay, you always write down the given stuff first. Now sometimes the given isn't in a statement, it's just in the picture, and that's okay. So we are given that AB is equal to BC and AD is equal to CD. Okay. Now technically I should be putting bars over this and using the congruent symbol, but I'm not going to be that nitpicky. Alright, so these 2 were given in the picture. Given. Right here, in symbol form, it was told to you. Okay? We need one more side. I'm going to introduce a new property in this proof. BD is a side for this triangle, and it's a side for that triangle. Do you agree that anything should be congruent to itself? Yes, that's called the reflexive property. So anytime you have 2 triangles that share a side, so this side is the same for both triangles, then you're going to do BD is equal to BD. And that's going to be called the reflexive property. So anytime you're looking at a proof and this is the same thing as that, it's going to be the reflexive property. Do we have 3 sides? Side, 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 right? So can I say that the triangles are congruent? Yes. So triangle ABD is going to be congruent to triangle. Now you do have to be careful with the letters here. The letters have to correspond to these letters. Which one corresponds to A? C. It's going to be the C there. B is the same thing, and D is the same thing for both triangles. And my justification here is this property. If the 3 sides of the triangle are congruent, then the triangles are congruent by side, side, side. Okay? Might be a little shaky on that one. Let's do another one. Let me show you another one. And I could go a little slower, but I want to make sure the video is under 20 minutes long. So if it feels like I'm rushing a little bit, that's why. If you have any questions, we'll figure it out during class. Okay? Okay, so here's your picture, and again, we want to prove the triangle's congruent. So Okay, so in this case, you don't just have a picture, you have a picture and a given statement. Okay, but we still have to write down all the given statements first. So AB is equal to CD, BE is equal to EC. Now, every year I have a lot of kids that want to go ahead and say what I almost wrote here. They want to say AE is congruent to ED and say given. Is that what this says? If it isn't word for word, your given statement can only be word for word. So this doesn't say they're equal yet. All it says is that E is a midpoint of AD. That is what we're given. But you would be correct. These are equal, aren't they? But you have to justify it. Why are they equal? Because of that word right there. Because that's what the definition of that word means, is that if this is a midpoint, then those two are equal. Now do I have a side, and a side? So the triangles are congruent. Triangle ABE is congruent to triangle, and I'm going to do DCE because that's the way it corresponds. And that's congruent by side, side, side. Okay? Alright, so I did the first half of notes in 7 minutes, so I've got a little bit of time. Let's go back over it just to make sure. If you have 3 sides of a triangle, then the triangles are congruent. Let's look at the proofs again. We were told these were congruent. It was told to us in the picture. So we wrote given. These two are congruent because they are the exact same side. That's the reflexive property. So the triangles are congruent because we had 3 sides, so that makes it the side, side, side postulate. For my regular ed kids, guys, you're not going to be asked to do this entire proof by yourself. I'll probably give you the left-hand side, and if you can justify it with the theorems, then that's good enough. Okay? If you can apply those theorems to a situation, that's what our learning goal is. Okay? Or it's part of our learning goal. So don't freak out too much. You're not going to have to do this completely on your own. Alright, so the next one we were only given 2 sides congruent. And we had to figure out that the third side was congruent because of this word right here. Okay, we couldn't just put this down as given because it wasn't in the given statement. We had to justify it, but we pulled out this word to justify it. And then we had 3 sides, so the triangles are congruent by SSS. Alright, I'm going to move on to part 2. Alright, the SAS postulates. SSA postulate says if 2 sides and an included angle are congruent, then the triangles are congruent. Alright, so in this one we don't need all 3 sides, we just need 2 sides and 1 angle. And we don't need the rest of the triangle, just those 2 sides and 1 angle. But it's a very specific angle. They call it the included angle. Let's talk about what included means. Okay. I like to think of it as in the middle, but some kids don't see it that way. Every year I have a couple of kids that really struggle with what it means to be included. Okay. Let's look at angle A. Angle A is included in which 2 sides? Okay. If this is angle A, then this side and this side is where it is included. So AB and AC would include this angle because it's in the middle of this one and that one. Let's look at angle B. Angle B is included between this side and that side. This side is BA, this side is BC. And angle C is this angle right there. it's included by this side and that side, which is CB and CA. Some of you are looking at me like, why is she spending so much time on this? It's really common sense. Other people who are not as visual are like, wow, I didn't understand that at all. So be respectful of each other in the classroom when we talk about this, because this is really one of those polarizing topics. Some kids get it really easy and some kids do not. And it's just all about the way your brain's wired. It doesn't make you smart or dumb. It's just you might be really smart. You might have an A in this class and not get this. So please be respectful to each other when you're talking about this. Alright, so now that we know what included means, okay, included angles, so these are included angles. Later on in another section we'll talk about included sides. Okay, so let's talk about our sides. AB. Included means in the middle, right? So what AB is included between which two angles? Well, if this is AB, then it's going to be angle B and angle A. Let's look at BC. If this is BC, then it is included between angle B and angle C, because that is the angles that are on each side of it. And then AC is included between A and C. Okay, so that's what included means. Alright, 2 more proofs using the SAS and then we're done. And we've got 8 minutes left, so hopefully I can keep it under 20. Alright. Okay, like I said, you really have to know theorems here. Yeah, I think that's all that's given. Oh, not theorems, symbols. You really have to know your symbols in this section. These symbols mean parallel. These symbols mean congruent. So these lines are not only just parallel, but they are also congruent. Okay? So AB is parallel to DC, and AB is equal to DC. That's given. And we're trying to prove the 2 triangles congruent. So, what else can we say about the picture? Well, if you remember from the first example, if 2 triangles share a side, then can we say it's congruent to itself? Yes. DB is equal to DB, and if you don't remember what property it is, you can look back now. It was the reflexive property. Anytime you have something equal to itself, that's the reflexive property. Okay? So that gives me, now once you're doing a proof, you want to add to the picture. You're originally just given this symbol, but we just proved that. So I'm going to go ahead and add that to the picture. Now, these lines are parallel. So, anytime you have parallel lines and a transversal, you're going to have congruent angles. Which ones are congruent? Well, what about that one and that one? Are those 2 angles congruent? Yeah. Can anybody tell me why? ABD is equal to angle CDB. These are alternate interior angles, so that makes them congruent. Okay. I have a side, and an included angle. A side, and an included angle. Are the triangles congruent? Sure are. Triangle CDB. Notice I had to switch the letters here, okay, because this was ABC, and then this is DCB, is what corresponds. Alright, and then this is our postulate, SAS. We have 2 sides and an included angle. So this is SAS. Alright, that was example 3. Example 4. Okay, if I give you that picture and ask you to prove the triangle's congruent. First, start out with the given. EB equal to ED. AE is equal to EC. That was given in the picture, not in words, but in the picture. Okay. Alright, do you see anything else congruent? Any other congruent angles or sides? Well, I hope you do, because we've been learning this since Unit 1. What about that angle and that angle? Are they congruent? Yeah, you bet they are. So angle BEC is equal to angle DEA. Anybody know what kind of angles they are? Vertical angles. Okay. Do I have two sides and an included angle? Two sides and an included angle? Two sides and an included angle. So my triangles EEA are congruent because of side angle side. Okay? I do have kids every year that get confused about these symbols right here, the difference between the angle and the triangle. Even though these letters are exactly the same, this symbolism is talking about just the angle. This symbolism is talking about the entire triangle. Okay, so that may be a little bit confusing. Hopefully I cleared that up. Alright, I'll answer any of your other questions in class. Like I said, hopefully you're not too frustrated with this lesson. It should just give you kind of a background, and then we'll go over it in class, and you need to have this out when you're doing the homework, because your proofs and your homework will be very similar to this. Okay?